like here for the next few days. Here we are, it's the 27th, 28th, 29th, 30th. So here'd be the 1st. I believe Wednesday's the 2nd. That make this the 4th. 6, 7, 9, 11. I think that's right on the dates. Does that work out about right, calendar-wise? Okay. I like to give at least a week's warning on it so that you've got some time to get study time scheduled in, and it isn't just, whoa, it's coming tomorrow, and now what am I going to do type of thing. Which would make the earliest date not till next month, in October. Okay? So the earliest date that I would be looking at would be Friday, October 4. Some other options would be Monday, October 7, Wednesday, October 9. I hate to push it back too much further than that because that's getting to be a lot of material then. And oftentimes, unless folks are more comfortable doing it otherwise, and let me know if you are, we can work things out. If, for example, you choose to have the test on this date, okay, so if you choose the 4th, the last new material, the last test material would be Monday, September 30. And the reason for that is last new material's there, but it gives you a chance to ask about it here and get things squared away before you're tested on it there. Does that make sense? So the cutoff for material on the test is often 2 classes before the test. Okay. If you want, we can cut it off earlier, but just remember that puts more on the second test. It isn't like you avoid it in any way, it's just putting it off, which, you know, it's your call, it's your test. Do you have any questions on how things work, or plans, ideas, suggestions for other dates? Everybody good? Okay. And if you want, let's just go ahead and vote on it. And if it's really close between 2 of the dates, we'll just treat this as the primary and then get it down to 2 dates and have the runoff between those 2. You only get to vote once. Okay. How many of you want it on Friday, October 4, which would be a week from today? Whoa! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Looks like about 14. That may be a tough number to beat this morning. Okay, but just for grins, anybody going to cast a vote for Monday, October 7th or Wednesday, October 9th? Okay, there we go. Go ahead and vote, right? Okay, so it's looking like by a large vote, Friday of next week will be the test. Now, if the test is next Friday, what's the last date for material on the test? The 30th, which will be Monday. So the stuff today will be on the test, as well as whatever we get covered on Monday. Okay? So we'll jot down 8 a.m. Test 1 is going to be Friday, October 4th. Okay. I usually try and get stuff graded and back to the next class. Depending on how many classes choose to have it on Friday, it may be a day or 2 delay because this semester I'm teaching 5 classes. Any idea how long it takes me to grade a test? A set of tests, a class set? Probably like a half hour or something, right, to grade a test set? It's more like 4 hours. So if 2 classes, well here, if 4 of my classes choose to have the test on Friday, October 4th, that's 2 8-hour days, isn't it? Oh, that means Saturday grade for 8 hours, Sunday grade for 8 hours. And my wife will be letting me know that this is getting ridiculous. Okay? So that's why things sometimes get bounced back a little bit. But it does take a while because I grade on partial credit, which means I got to follow every single line that you put down, every single thing, try and figure out the stuff that's going up the margins and all that jazz. Okay, so test 1's going to be when? Friday, October 4th. It'll cover everything in the review sections that we did. Okay. So remember working with the logs, the exponentials, doing the regression models on your calculator. Ooh, you still got to know how to do that? Yeah, for the rest of this as well as 1045, you got to know how to do that. Okay. And it'll also include all the information we've covered on derivatives. What's question 1 on the test likely to be? Question number 1. Okay, very close to that one. Okay, and it's checking to see if you know what a derivative is. It'll just say, using the definition of a derivative, prove, and I don't know what the exact problem's going to be. Prove that the derivative is, let's say 64x plus 12 when y is equal to 32x squared plus 12x minus 9. Now, what's the definition of a derivative? Is that the power rule? No, that's a shortcut, isn't it? What's the definition of a derivative? Yeah. Okay, it's going to involve that difference quotient, isn't it? Way to go. Okay, that's going to be starting out with y prime equals the limit as h goes to 0, f of x plus h. Is this looking familiar? And I mentioned the other day, you can practice these all you want because you can take any old quadratic you want and you can look at it and write down the derivative, can't you? Now, I'm careful in the way I word this because I give you the function and the derivative. So if you just use the power rule to get the derivative, how many points partial credit you going to get? None, because it's part of the question. It's already there. Okay, so you've really got to know what's going on. This is going to wind up being this limit as h goes to 0 of, let's see, 32x plus h squared plus 12x plus h minus 9. Does everybody see where that came from? Is that looking familiar? Okay, minus 32x squared plus 12x minus 9, and it's all over h, isn't it? Okay. So this is going to be equal to the limit as h goes to 0 of, first thing I'm going to do is to deal with what is inside of this set of brackets here. And the first thing inside of that set of brackets is the 32 times the x plus h squared. So that's going to square out to be x squared 2xh plus h squared plus, then I'm going to distribute to 12, 12x plus 12h minus 9. Then you got to be careful in the second part of this. What's the dangerous part in the second part of this? Only doing the negative for the first term, right? Everybody knows it's going to be minus 32x squared. But it's also going to be minus 12x, and then it's going to be plus 9. Does that make sense to everybody? Because you got to be careful to distribute that negative everywhere. Okay, so this is going to give us the limit as h goes to 0. And it's going to give us 32x squared plus 64xh plus 32h squared plus 12x plus 12h minus 9 minus 32x squared minus 12x plus 9 over h. And I know I'm going kind of fast. Okay, I trying to improve your speed. But I noticed nobody's screaming too badly, so it is sort of making sense. That or you've gotten to the point where you're numb, one or the other. Okay. Go ahead and combine like terms. You've got the plus 32x squared and a minus. We have a plus 12x and a minus. We have a minus 9 and a plus 9. So that's going to give us then this limit as h goes to 0. I'm going to intentionally skip a step or combine two steps. On the next line, I'm going to copy down everything that's left in the numerator. However, everything that's left in the numerator has a factor of h. So as I copy it down, I'm going to factor out that h, and we'll get 64x, 32h, plus 12. Does that make sense to everybody? Are you allowed to do that on the quiz, test, or whatever? Sure. It's kind of a reasonable step to combined. So that's going to give us this limit as h goes to 0 of 64x plus 32h plus 12. Now, this function that we have, this 64x plus 32h plus 12, is that a continuous function? Or does it have places where it blows up, if you would, or is undefined? Let's see, undefined would be zeros in denominator. Do we have any troubles with 0 in the denominator on this one? Nope, not even a denominator. Do we have any concerns about square roots? Oh, no square roots. So is it legal to just plug in 0 for h? Yep. So if you plug in 0 for h, you get 64x plus 12. Ta-da, you're done. Okay, I think that's what I started out with somewhere up here. Yeah, here we go. 64x plus 12. You've proven now that the derivative is 64x plus 12. And I will be careful in the wording of the problem to pretty much state it like that, where the derivative is given and the original function is given. So just being able to do the derivative is not going to get you anywhere on this one, because what's really being tested for in a problem like this? Do you know what the definition of the derivative is and how it works? Okay? Question number 1, how many points? Usually about 10. 10 points right there. Now that's good news, because that's a whole letter grade you can pick off right early. It's no big surprise. It's no wonder what's going to be on the test type of thing. There it is, question number 1. Okay? How can you practice this on your own? Just sit down and write a whole bunch of quadratics. 2x squared minus 8x plus 9. Y equals 11x squared plus 4x minus 8. Y equals, let's say 5x squared. Hey, let's do a negative 5x squared minus 3x plus 2. For each of those, do you already know what the derivative is? Yeah. Okay, in this first case, the derivative is going to be, it's going to be what? Yeah, 4x minus 8. The second one, the derivative is going to be 22x plus 4, isn't it? The third one, the derivative is going to be a negative 10x minus 3. For each of these, as you use the original function in the definition, you should eventually get the derivative that you already know is the answer on the right. The only thing that you need to be careful of is make sure that you get all the algebra correct. Does that make sense? One of the things I want you to realize is that you're not powerless, and you're not, I did all the homework problems and now I've got nothing to practice with. That's not true. One of the other things that I found useful is I was cruising through various courses. It worked particularly well for calculus because the library has lots of different calculus textbooks. If you go to the library and turn to the section on definition of a derivative, they'll have problems worked out in the section, won't they? Before the homework. Okay? What I used to do is I would just flip the book open. I would quick cover up the solution with a piece of paper. Why'd I do that? So I couldn't see it. Because on the test, is the solution really going to be there to check along the way? Not so much. Okay? So I would cover up how they worked it out. I would just start the problem, work it out on my own, and then when I was done, if I'm thinking, I wonder if I got this right, look, it's all worked out right there on the page, step by step. Check the answer. If you got the same answer, you're all good. If you don't have the same answer, I wonder how they got that one. And look at the step-by-step stuff. Lots of textbooks in the library from calculus. Okay? So lots of opportunities there to practice those. Does that make sense? Okay? I found that worked really well for me over the years when I was cruising through various classes. Okay, so there's that one done. Hey, what if you do one of these, but it takes you 45 minutes to get one of these done? Is that good news or bad news? That's bad news. Why is it bad news? That's right, it's taking you forever to do one problem. You've got 45 minutes into this one, but how much for the whole test? 55. That means you get to do the other 90 points in 10 minutes? Whoa, that may not happen, right? Or it might be a painful, okay? So part of the objective is to just get quick on this. I know that some of the quizzes and some of the tests are going to start to feel tight as we move on in the semester and the year. And that's not because I like tormenting you. It's because I don't know where you're headed career-wise. Do you really know where you're going to land career-wise? Probably not. You're going to interview for some jobs and whoever offers you a good deal is, yeah, I can do that. Right? I got to go home tonight and watch some YouTube videos and figure out what I'm doing that I just agreed to. Okay? So part of what I'm after here is just you getting fast on stuff. Because you can't take 2 weeks at the office working out a problem. Does that make sense? Okay. All right. Do you have any questions about any of the homework problems, or are those all working for you? We were doing product rule in section 1.6. Okay. Let's do a quick example of the product rule. Just a quick reminder. If you have something like the following, and I'm just making this up right now, and you can do it yourself, okay? Product rule means you're going to have two things multiplied together, aren't you? Okay, so I'll stick some stuff in the first one and then stick some stuff in the second one and do the product rule. So let's say this is something like 6x squared minus 8x. Let's say this is the square root of x plus, let's say 3 over x. Just throwing some different stuff in there to kind of mix it up a bit. Because this year you're going to see functions that aren't just x squared, x, and a number. Okay? Those days are long gone. Okay? Derivative. Well, let's see. The derivative equals, oh, wait a minute. I could have also written it as dy over dx, because that means the same thing, doesn't it? Well, let's see. It's a product because we have this piece times this piece. Actually, each piece is called a factor since it's multiplied. It would be a term if they were added or subtracted. I'll call this first factor f and the second factor g. Does that make sense? Does anybody recall what the product rule is? Yes, sir.
F prime G plus G prime F.
Okay, f prime G plus G prime F. Now, some of you may be sitting there thinking, well, wait a minute. I don't remember it being like that. I thought the second part was F G prime. Now we're going with G prime F, and Chuck said that's okay. Did he forget the other way? Why are those two things equal? Yeah, when you're multiplying two things together, does it matter which order they're in? 2 times 3 is the same as 3 times 2. It's called the commutative property of multiplication, and you see it in action right there. Well, gosh, Chuck, which way do you want us to memorize the rule? I don't care. Whichever is easier for you. They both work. Okay? But, especially at the beginning, it would be wise to jot it down, because it gives you a blueprint, doesn't it? Now you've got a way to build stuff. Well, is f prime easy enough to do here? Yeah, that's pretty easy, isn't it? It's going to be 12x minus 8 times the square root of x plus 3 over x plus, right? Remember the plus. That's the easy part to forget. Now, let's see. For g prime, that's this portion right here. This can be rewritten as x to the 1/2 plus 3x to the negative 1. Does that make sense on rewriting that? Okay. So for g prime, the derivative of x to the 1/2 is going to be 1/2 x to the negative 1/2. Does that make sense? Then it's going to be plus. Now in the second one, that negative 1 in the exponent is going to be times the 3. So that's going to be plus a negative 3. But plus a minus is just minus 3x. Negative 1 minus 1 is negative 2. You're out of the woods. The rest of it's just copying stuff down. F is just 6x squared minus 8x. And you know what? You're done. That one's done. Does that make sense? Okay? That's all there is to the product rule. That's it. People often seem to kind of like the product rule because it's pretty easy to get the hang of. It works the same every time. It's easy to know when you're going to use it. You only use it if you have one factor times another factor. If you have one thing times something else, it's product rule time, right? Does that one make sense? Pretty straightforward. This stuff's doable, isn't it? And the cool part here is with this, you can really look at the function and write down what the derivative is, can't you? I mean, there's no middle steps, no whatever, just boom, and write it down. You're actually doing the calculus in your head. Don't go telling a lot of people calculus is really easy, I just do it in my head. Because they're going to start using 4-letter words on you, like nerd and geek. Okay? But calculus is easy. You can do it in your head. Okay? We'll keep that a secret just between us. This makes sense? Everybody's good? Okay. I'm looking at the clock thinking we got maybe 10 minutes, tops. I handed out a paper today. If you didn't get one of them, anybody need one of these? Okay. Make sure everybody got one. There you go. No, I'm going to use the quizzes for the sign-in sheet today. How about that? Okay, anybody else need one? Everybody's good? We'll go over these probably on Monday. If you take a look at these, look at this stuff. Does this kind of look like the definition of a derivative? In both of these, for the product rule and the quotient rule, you can see where the rule comes from. And where does it start? By using the definition of a derivative. Oh, wow. Everything goes back to that. Okay. However, for right now, we'll take a look at that on Monday because it takes a little bit longer. Let's dive into the second part of what's going on here in this section. The quotient rule. Quotient means we're going to be doing some dividing, right? Let's just dive in and do an example or two. So an example would look something like if y equals 5x squared minus 8x over 11x plus 4. First question is, does that particular function simplify any? Can we factor the numerator and cancel it with something in the denominator? It's not going anywhere, right? We're just stuck with it the way it is. Okay, some of you may have seen this rule in high school or elsewhere. Some of you may not. There are a couple ways to write it down. Okay, I'm going to show you the way I really remember it. Hi and ho. I showed my daughter it and she said, "That's stupid, Dad." But the problem is, it's stupid funny, and now she's got it remembered. And that's the whole point of it, is coming up with some way of you remembering it, right? Equals, let's see. There used to be an old comedy show on, Home Improvements. Anybody ever see it? With Tim the Toolman Taylor, always doing some fun and crazy thing. Had a neighbor. What was the neighbor's name? It was Wilson. Now the question is, was that his first or his last name? Actually, it was both. His name was Wilson Wilson. Okay? And Wilson would always look over the fence, and you never saw anything below his eyes, so you never saw the rest of his face. So he was on this program for years, and you never even know what he looked like. Every shot of him was always from here up, or he'd be wearing a mask or something or other that would fit in. Okay? But he would always look over the fence to Tim and he'd say, "Heidi ho, good neighbor." And I always remember that, Heidi ho, because in this is hi, de ho. Oh no. That's the second part of the quotient rule. Now the first part is just the opposite of it then. It's going to be ho-de hi. Ho-de hi minus Heidi ho, good neighbor, over, and then Santa Claus sort of comes in. We have ho ho. Or another way to write ho ho is that squared. If you look in math books, they won't have this. What they will have is f over g and y prime equals f prime g minus f g prime over g squared. Couple things to be careful of. This differs from the product rule in that you're not adding the two terms, are you? You're subtracting. Does the order make a difference now? Yeah, because with subtraction, you all know you've got to be careful. Denominator is squared. Which way do you want, or should you memorize it? Whatever's going to work for you. If you ask me, now Chuck, what's the quotient rule again? I will, because this is a math class, I will most frequently give you this. But anytime you ask me, Chuck, what's the quotient rule, you'll see a pause. And what's going through my mind is ho-de hi minus Heidi ho, good neighbor. And then I've got to translate ho-de hi. Okay, the d high, well, up top is the f. Down the bottom is the g. Minus, being careful, minus high. Well, what's up high? That's the f. D ho, good neighbor. That's the derivative of what's down there. And you'll see it. What's the quotient rule? And there'll be a pause, and then f prime g minus f g prime over g squared. I don't have that memorized. I just think back to a TV show I used to really enjoy watching. Okay. Okay, so with that laid out and two ways to go about it, you figure it out. Don't bother doing any of the multiplying or anything, just write it down. What's the derivative of that function? You can do this. Just do it one little piece at a time. What's the first factor in the numerator? The first little chunk. Isn't it f prime? Yeah. Can you do f prime? With your brain tied behind your back now. What's the derivative of 5x squared minus 8x? Ta-da! 10x minus 8. Well, that's way too easy. Then the next thing is to copy down g. Well, g is the denominator. Remember, f is the numerator, g is the denominator, and you don't have to do anything with it. You just copy it down. Minus, now it says to just copy down what? F. Well, you can do that. 5x squared minus 8x. Now it says to take the derivative of the denominator. You can do that really easily. What's the derivative of the denominator? It's 11. Then, in the denominator, it says just, well, copy down what's in the denominator. And do what to it? Square it. And you're done. That's all there is to the quotient rule. That's it. You gotta be kidding. I can look at this stuff and just write down the answers? Yes. Well, that's good news. This test may have some easier points to it than what everybody was telling me. So everybody rolls their eyes when you say calculus, right? Or get back. No. Drive a stake through it. Are you good with this on the quotient rule? Okay. Monday, we will go over this sheet that I gave you today. So be sure that it makes an appearance Monday. On where did these two rules come from? I want you to realize that this stuff with the definition of a derivative really is handy. And you don't have to memorize the product and the quotient rule. You can rederive it every time using the definition of a derivative, but I think after you see these things, you're going to decide to just memorize it. Your call. Okay? Are you good? Everybody okay? I'll get some homework up for section, this is what, 1.5, 1.6, I forget, 1.6. Okay, thank you. Everybody good? All right, quiz time. Woohoo!